Let's go through another question. Question 3. A foam generator consists of a horizontal tube of circular cross-section which tapers from an input of 80mm internal diameter to 20mm diameter. Now 750 litres a minute of concentrate with a density of 1200 kilograms per metre cubed is flowing through the generator and the pressure inlet is 12 bar. What is the pressure at the point where the diameter is 20 millimetres? That's the question. Remember, what is the first thing you're going to do? Produce a sketch. Produce a sketch explaining what this is. And this shows you on here. Put a point A, put a point B. At point A, 80mm diameter, pressure's 12 bar. Point B, diameter 20mm, pressure you don't know. That's what you're trying to work out. Do you understand the situation? That's what you're trying to work out. Next, you need to write down the equation in the correct format. What's it quoted in? Bars. If it's in bars, this is the formula here. That's the pressure in bars. PA times 100,000 and PB times 100,000. That's if it's quoted in bars. That's the formula to apply. Next, we need to determine the velocity energy of the water using the continuity equation. So don't forget, we need to know the continuity equation. Now that is Q equals VA. And therefore, by transposition, V equals Q divided by A. Now, first of all, let's determine the velocity energy at point A. Don't forget, you've got to convert to SI units straight away. Now, Q is metres cubed a second, and in this case, it's quoted in litres a minute, so you've got to convert it. How do you convert that? Well, Q equals 750, you divide it by 1,000 to get metres cubed, and then divide it by 60 to convert to metres a second. Do you understand why you're doing that? So that gives you Q equals 750 divided by 1,000 divided by 60. Q in metres cubed per second is 0.0125. That's what we need, Q. We've got the Q. Now, again, like I say, we need to work out the velocity using V equals QA. So we need to work out the area. We've got the diameter in millimetre. We need to work out the area in metres squared. To determine the area at point A, we'll use the formula again, 0.7854d squared. Substitute in, you get A, the area of the A equals 0.7854 times 0.08 times 0.08, because it's 80mm, equals 0.005027. That's in metres squared. Therefore, the velocity at A, when you bring Q in, VA equals Q divided by AA. Velocity at A is 0.0125 divided by 0.005027. The velocity at A is 2.487 metres a second. So we've worked out the velocity at A. Let's work out the velocity at B using the same format. When you use the same format, VB equals Q divided by AB. We need to work out the area at B. Area at B is 0.7854d squared. 0.7854 times 0.02 times 0.02, don't forget it's 20mm, gives you the area at B is 0.000314 metres squared. Substitute it in, VB equals Q divided by AB. VB equals 0.0125 divided by 0.000314. The velocity at B is 39.81 metres a second. So now you've got the velocity at A and the velocity at B. So now you can substitute it into the velocity energy. Once you've got the velocity, you can work out velocity energy. So don't forget, this is the formula for bar, PA times 100,000 plus rho GHA plus half rho VA squared equals PB times 100,000 plus rho GHB plus half rho VB squared. Now don't forget, wherever you take the datum line, centre of the pipe, what happens to the potential energy? Zero at both points, no potential energy. You can cancel it out and have this formula here. Now you're substituting all your known values, put them in. So what have you got? Well, you know the pressure, 12 bar, so it's 12 times 1,000, 100,000 is 1,200,000 plus half times 1,200, that's the concentrate density, times 2.487 squared equals the pressure at B, that's what we're trying to work out, times 100,000 plus half times the density, don't forget the density is 1,200, times 39.81 squared. Substitute in all known volumes. You multiply that out, you get 1,200,000 plus 3,711 equals the pressure at B times 100,000 plus 950,902. Transpose again by cancelling out the 950,902 from both sides, gives you 1,200,000 plus 3,711 minus the 950,902, and that gives you 252,809 equals PB times 100,000. All you do, divide both sides by transposition by 100,000. It gives you the pressure at the B equals 2.528 bar, or 252,818 pascals. That's what the question was asking you. What is the pressure at B? It's 2.528 bar, or 252,818 pascals. That is how you solve questions like that. And that completes question 3.